Okay, team, let's talk architecture. We're going to break down one of the biggest questions we're all wrestling with when it comes to LLMs, long context versus RAG. This is one of those foundational decisions, you know? It can make or break a project, so let's really dig in and get it right.
And we all know this feeling, right? It was pure muscle memory. You get a doc that's too big, you need to query it, and bam. The answer was always RAG. You chunk it, you embed it, spin up a vector DB, and retrieve the top few results. It was the pattern we reached for without even thinking about it.
But then, the whole world shifted under our feet. Models like Gemini 1.5 Pro didn't just nudge the context window bigger, they blew the doors off. We're talking windows that can swallow an entire code base, or a full year of customer support tickets. Just all of it.
And that's the absolute key takeaway here. This wasn't just a small step up, it's what some are calling a regime shift. It means that our old reflex, that automatic let's build RAG reaction, well, it's just not good enough anymore. A completely new architectural path just opened up, and we have to actually stop and think.
So the real engineering question isn't just can we skip RAG, but should we? And the answer, as it almost always is, lives in the trade-offs. We're talking about a classic three-way tug-of-war between cost, latency, and the sheer complexity of the system you have to build and, more importantly, maintain.
Let's start with the 30,000-foot view, right? On one side, you've got long context stuffing. It's kind of beautiful in its simplicity. It's just one API call. That's it. But that one call can be pretty darn expensive and slow. On the other side, you've got RAG. It's way cheaper and faster for each individual query, but now you're on the hook for a whole pipeline of moving parts. You've got a vector database, maybe a re-ranker, and all the operational headaches that go with keeping that machine running.
Let's put some real numbers on that cost piece. That first bar, $150 for uncached stuffing. Yeah, that's what makes everyone nervous. But look what happens with a simple cache. The cost absolutely plummets. Now, RAG is still cheaper on a pure per-token basis, no doubt. But that's not the whole story, is it? The number you really care about is the total cost of ownership. Long context has a higher sticker price per token, but it is dramatically cheaper in terms of your time, engineering time, and your infrastructure bill. That's a trade-off that's definitely worth thinking about.
And of course, tokens don't just cost you money, they cost you time, a lot of time. If you've got a user sitting there staring at a chat window waiting for an answer, making them wait for a 1,000,000 token prompt to process is going to feel like an eternity. Long context stuffing is really shaped for things that happen in the background, like an async job or an overnight report. RAG, with its super fast retrieval and quick little LLM call, is built from the ground up for those interactive user-facing moments. So the rule of thumb is pretty simple. If a user is waiting, latency is king, and RAG almost always wins.
But here's the silent killer. This is the failure mode that all those fancy needle-in-a-haystack benchmarks don't really show you. It's called context dilution. This is when the model technically has the right information buried somewhere in those million tokens, but it just gets distracted by all the other, sorta relevant noise around it, and it ends up giving you a worse answer.
So what does this actually look like? Well, you'll see the model start to miss important details, or it'll fail to connect dots between different parts of the text. It might even start hallucinating more. And this is where you see a hidden strength of RAG. You know that limit where it only shows the model the top, say, 5 chunks? That's not a bug, it's a feature. It forces the model to focus on a small, highly relevant set of evidence, which is the perfect weapon against context dilution.
Okay, so given all those trade-offs, when does just pasting it all actually come out on top? Because there are definitely some really important scenarios where stuffing the context isn't just a viable option, it's actually the superior architectural choice. Here's your checklist. If you're dealing with messy, unstructured stuff like raw meeting transcripts, long context is your friend. Or if the questions you're asking require a global understanding, synthesizing ideas from the beginning, middle, and end of a document. Long context is built for that. Same goes if your corpus is pretty small and doesn't change very often. In these situations, the simplicity and the lower engineering overhead just make it a no-brainer.
But here's the real secret, the thing people are figuring out right now. Framing this as a binary choice, RAG or long context, is often the wrong way to look at it. The most robust, highest quality production systems being built today, they're actually using both.
So here's how this hybrid model actually works. Instead of a retriever that's laser-focused on precision, just grabbing the top 5 best chunks, you use a recall-heavy one that's designed to grab the top 50, maybe even top 100 most relevant documents. Then you just stuff all of those into a long context model and you let it do the hard work of reasoning across all of that evidence. So think of it this way. RAG prunes the giant haystack down to a manageable size, and then the long context model meticulously finds the needle.
And what's so powerful about this is that it completely solves the single biggest, most frustrating failure mode of classic RAG. We've all been there, right? Where the absolute critical piece of information was in chunk number 6, but your retriever only gave you the top 5. This hybrid pattern gives you the awesome scale of retrieval with the deep, comprehensive reasoning of long context. It really is the best of both worlds.
Okay, so let's make this super practical. How do we take all this theory and use it to make the right call for the projects we're starting on Monday? Let's walk through a decision framework. Before you write a single line of code, you have to answer these questions. How big is your data? How often does it change? What's your latency budget? What kinds of questions are your users actually going to ask? The answers to these will point you toward the right starting architecture. But honestly, the most important one on this list is the last one. You have to build an evaluation set of real questions with known good answers first. Don't guess which architecture is better. Measure it.
And ultimately, that's what this all comes down to. We're moving out of an era where we just followed a default pattern. Now we're in an era where we have to consciously, deliberately choose the right tool for the job, for each specific problem. Yeah, it requires more thought. It requires more measurement, more intention. But that's not a burden. That's our job. That's the craft of engineering.
If you found this helpful, hit subscribe and the bell so you never miss a video.